Welcome to Business Math. Today is February 12th. Last time on Monday, we went over some huge concepts about statistics. What's one of the huge concepts that we went over on Monday? I gave you like 5 huge concepts. Name me one of them, Rachel. Oh, Rachel stepped out. Okay, let's go to Wyatt.
Statistics.
Yeah. 5 huge concepts. Name me one.
Frequency. Was that what you were? Frequency distribution.
Well, you get 2 points for your good participation. Okay. Name me one of the 5 huge concepts. Jonte.
5 huge concepts. I just got it. Can you repeat? 5 huge concepts
Of statistics. Name me one.
standard deviation.
Standard deviation, okay. Good, I like that. All right, 2 points for your good participation. All right, let's go to Shay. Let's see. Oh, Shay was not here, so she's got a good excuse. Let's see. And how about, and see, Robert wasn't here. So let's see, let's go to Courtney.
Random sampling.
Yes, the concept of a random sample. This is huge. It is very, very important that any type of statistics that you take a look at when it says, okay, these people were surveyed, and here are the results of the survey. Okay? So one of the huge concepts is the concept of a random sample. This is absolutely huge. These are huge concepts of statistics. All right. Number 1, the concept of a random sample. Because many times, what will happen is, the sample that was selected wasn't even random. And you're drawing conclusions based upon a sample that wasn't even random. So one of the things we talked about was people with home telephones. Nowadays, people with home telephones are usually old people. Young people, most young people don't have a home phone. Most young people, hey, cell phone is fine. So that's an example of, if there's a phone survey, you need to be skeptical about the results, because probably it didn't involve young people. All right? If it was a phone survey. On the other end of the spectrum, if it was a survey that involved email, most old people don't have an email address. So if it was a survey about whatever it might have been, if it was an email, it was a survey sent out by email, it's probably going to be a biased sample. Because, and in fact, if it's a survey about technology use, and you use technology to assess the results of a survey, well, it's going to be definitely a biased sample then. So you have to be very careful. Random sample is the first huge concept. Good job, Courtney. In fact, I'm going to see, Courtney, it's rough to be awake in the morning like this. So you get 2 points for the first person, extra credit, by the way, for the first person to catch that was one of the huge concepts. Now let's see, another huge concept. That was just one of 5 that I gave you. Another one, Rachel, what's another huge concept?
What it means. What it means.
Oh, mean?
Yeah.
Mean, and mode. So the concept of what average are you using? The concept of average. Are you talking mean, median, or mode? Very, very important there because, again, this is a concept of, I'll leave that up there a little bit longer. The mean, as you're going to see in this particular chapter, in fact, I think that is in today's, yes, that is in today's section. To find the mean of some numbers here, you add them up, divide by the number that there are. So let's say we are doing, we're doing average salaries. And so what we do is we get a sample of people, and we get 10 people in the sample. So here are the 10 salaries, and I want you to, hopefully you bring your calculator with you to class every time. I want you to get the mean salary of these 10 people. So here's 10 people. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Here's 10 people. First person, they're making $12,000 a year, and the next person, they're making $15,000 a year. Next person's making 18. The next person's making 21. The next person is making 25. The next person is making 32. The next person is making 34,000. The next person is making 45,000. The next person is making 51,000. And the last person is making 62,000. All right. So let's see if you can find out right now. Go ahead and find out the mean salary of these 10 people. The mean salary of these 10 people. Go ahead. Do it right now. The mean salary of these 10 people. And you can round it to the nearest thousand is fine. Okay? The mean salary of these 10 people. And if you forgot to bring a calculator, well, then you'll just have to add them up by hand. You get to poke yourself in the eye with a sharp stick, right? Okay, what did you get for the average salary? And this is the mean that you're calculating. Robert, what'd you get?
31.5
There you go. So your mean, the mean salary of this was 31.5K. Whoops. 31.5K. So if you were going to round, to the nearest, you'd probably say 32,000, right? So 32,000 was the average salary. All right? Add them up. So when you add them up, you get 315,000. Okay, raise your hand if you got that same answer. All right. Good job. So now I want to change the data slightly. It just so happens that a friend of mine was included in the group. And he makes, I'm not going to tell you who he is, He makes $620,000 a year. Okay? $620,000 a year. By the way, you don't have to add all those up, because the other one was 62. Our total was 315,000, right? 315,000. So without adding them all up, we could take 620 minus 62, which is 558, and then just add the 558 on to the 315 to get the total. Okay, the question is, I just pulled a shortcut there. I verbally, I'll tell you what I did. I'll write it up here. The total was 315,000. That was before I jacked that one to 620,000. So what I did is I'm going to add on. I can't add on 620, but I can add on the 620 minus the 62. So that gave me a total of 873,000. So now what's the mean? Jay.
87.3 thousand?
Yeah, $87,000. So by changing one piece of data, the mean jumped from 32,000 to $87,000 a year. Now this is why you got to be careful of which average are you reporting. Because let's say this is a company, and there's 10 people in the company. They have one person, they're making 12,000, another person making 15, another person making 18, another person making 21, another person making 25, another person making 32, another person making 34. And now you got a couple people working white collar jobs, maybe in the office. They make 45 and 51, and the president of the company makes $620,000 a year. So in the annual report of the company, the president says, "Well, I would like to report that the average salary in my company is $87,000." Well, that's rather misleading, isn't it? Because the people start comparing notes. They go, we just saw this report that the average salary in our company is $87,000. So everybody starts asking everybody in the break room and says, "Hey, if the average is $87,000, some people, by the way, think average means half the people make above $87,000 and half the people make below $87,000. So they start asking each other. He goes, "Hey, Shay, how much money do you make?" Shay, you're employee number 8. "How much money do you make, Shay?"
It's not up. There it is.
I make 45K.
"You make 45,000. I go, "What?"
That's
See, and
cool.
I was making 51,000, and so I asked Shay. I said, "Hey, I'm the vice president here. How much? I'm only making 51. Shay's making 45. Robert, you're employee number 6. How much do you make?"
32,000.
32. And Rachel, you're employee number 7. How much do you make?
34K.
34,000. So in fact, in the break room, we find out that there's not one single person that makes $87,000. So, Jonte, you're the one that's really good with statistics. And Jonte says, I bet you I know what that president did. He used the mean. Way to go, Jonte. You figured that one out. Yeah. So the mean is very much distorted by one extreme piece of data. This is why number 2 is on the list. One piece of data. 10 people working in our company. The president making $620,000 a year. That one piece of data totally distorts the average. Now in this case, what would probably be the fairest average to report? The mean, the median, or the mode? What do you think, Wyatt? What would be the fairest average to report?
Probably the median.
The median, absolutely right. You win the $64,000 and the Buick. You'll have to contact Phillips University, and good luck on collecting that since they still owe me money. But anyway, the median is the middle score. That's the middle one. The middle one. So you order the scores from either low to high or high to low. And fortunately, I have them all ordered. I have 12,000, 50,000, 18,000, 21,000, 25,000, 32,000, 34,000, 45,000, 51,000, 620,000. So the middle score. Now, if there happens to be an odd number of scores, then it's easy to figure out the middle score. Because if I had 11 employees, then it would be the 6th employee. I do not have 11 employees. I have 10 employees. So that means, now let's see if anybody remembers how to find the median if I have an even number of employees. Courtney, do you remember how to do that? That's a good guess. I like it. I like that. Anybody else want to take a stab on how to find the median if you have an even number of data points?
Oh, you add them all up and divide by that number.
That's a good guess, because that's how you do the mean.
Oh,
We're doing
yes,
the-
for the median.
We're doing the median.
Add them all
Quiet.
up and divide them up by 5.
Well, that's a good guess, too.
You
Okay,
add the
Quiet.
middle 2 numbers and divide by 2.
There you go. You take the middle 2, which would mean this 25,000 here, and the 32,000 there. So you take your middle 2, because every time you have an even number of scores, you're going to have a middle 2. You're not going to have a middle 1. If you have 11 scores, if you have 11 scores, you're going to have 5 of them below. I started listing them as from low to high. You can list low to high or high to low, it doesn't matter. But if you have 11, you would have 5 up here and 5 down here. So it would be the 6th piece of data. And it doesn't matter if you ordered them high to low or low to high. You're going to have 5 here, boom, it'd be the 11th piece of data. But when you only have an even number of scores, then what you have to do is you have to add up the 2 middle scores and divide by 2. So right now, take 25,000 plus 32,000, add those up, and then divide by 2. 25 plus 32, divide by 2. So the median salary of this company is how much? Jonte?
28.5.
28.5 thousand. 28.5 thousand. That is halfway between the 25,000 and the 32,000. So halfway between these two. And if we rounded to the nearest thousand, we'd say 29,000. So 29,000 is the median. 29,000 is the median. better get the eraser going a little bit here. Okay, so this 29,000 right here, that belongs to the median. Median, 29,000. Okay? Now, which one, oh, by the way, the mode is just the most popular score, or the most popular piece of data, or in this case, the most popular salary. So, there's only one person with a salary of 12,000. There's only one person with a salary of 15,000. There's only one person with a salary of 18. There's only one person with 21, one person 25, one person 32, one person 34, one person 45, one person 51, one person 620,000. So in other words, you could either say there is no mode, because all of them are the same as far as frequency, or you could say all of them are the mode. But it's probably best to say, it's probably better to say that there is no mode. But if we had two people making 34,000, then that would be the mode, wouldn't it? If everybody else is one. Now, out of those three averages, mean, median, and mode, which one do you think is the fairest representation of salaries for the company? Rachel. The mean, the median, or the mode?
The median.
The median, absolutely. Because you see, now you're talking median, 29,000. So you start talking to people in the break room and you say, hey, the company report was just issued and it says the average salary at the company, and usually they'll even say median. They'll even, if it's a well-written report, it will say the median salary at this company XYZ. If it's not quite as well written, it'll say the average salary at this company. All right? But if it's well written, the company report will say the median salary is $29,000. Which actually does mean, that half the people in the company make more than $29,000, and half the people make less than $29,000. And in fact, see, the word median, hopefully none of you have ever been driving in the median. Now, if it gets real slippery outside, like we've had some pretty bad winter weather, semis drive in the median a lot because they can't even stop. I've talked to semi drivers, and that's what they do. If they can't stop, they'll head down into the median. And the median is the halfway point. Half the cars are supposed to be on this side of the median, and half the cars are supposed to be on this side of the median. That's the way it's supposed to be, isn't it? So you can use the word median when it comes to like an interstate highway. The median is the middle. Half the cars are supposed to be on one side, half the cars are supposed to be on the other side. So when you have the median score, or in this case, the median salary, half the salaries are on one side of the median, half the salaries are on the other side of the median. That's how you can remember what the median is. Half the salaries are on one side, half the salaries are on the other side. See, this is not true for mean, is it? It's not true for mean. And in fact, this is why it's one of my huge concepts, the averages, because if somebody wants to distort the data, let's say the president wants to distort the data and make people think in the community that he really pays his employees well. Well, which average is he going to use, Robert?
Mean.
He's going to use the mean, because that's the one in which makes him look good. you can go, well, the average salary in my company is $87,000. I really pay well. Boy, I'm a good president, good CEO. I pay about the average person in my company makes $87,000 a year. Well, that's distorted. So you need to be very careful when you're reading something when it says the average salary is this. When it says the average home value in the city of Enid is this. See, because guess what? Now, I don't know how much the Champlin Mansion is worth. What do you think? I've never been here in Enid. I've never been inside the Champlin Mansion. I can't tell you what the Champlin Mansion is worth, but I'm guessing it's probably worth about $3 million. Well, this is where, again, if you take a sample of homes in Enid, and the Champlin Mansion happens to be in those 10, you did a random sample of homes in Enid, and you came up with 10 homes, and one of them happened to be the Champlin Mansion. Wow, that would really screw up which one of the averages. Which one of the averages would that really screw up if out of the 10 homes that you randomly select from Enid, one of them was the Champlin Mansion? Shay, which one would that really mess up? Would it mess up? Yes, absolutely. It would totally mess up the mean. Because, here, just pretend for a second, just to make the numbers easy. Let's say all 9 other homes in the sample were worth 0. Now, there are some homes in Enid that are worth 0. If you've ever been to certain parts of Enid, you'll know, hey, you'll point to a house that is worth 0. All right. So pretend the other 9 homes were worth 0. So you've got 0 plus 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 3 million. Now, the total is 3 million. So now take 3 million and divide it by 10. 3 million divided by 10, what do you get, Courtney?
300,000.
300,000. So now you're going to report back that the average home in Enid, Oklahoma is worth $300,000. See, the mean in general can be a very distorted reporting of the average. So when it comes to average salary, when it comes to average value of a home, when it comes to the average net worth, when it comes to the average whatever, usually the median is a more accurate and a more fair representation of the average of the data. Because if we took 10 homes at random in Enid, and if the Champlin Mansion happened to be one of them, the $3 million valuation on the Champlin Mansion, that doesn't affect the median. Now, this is a tough question. This is to see if you really know, if you really understand what's going on. Why, when you do the median, the $3 million Champlin Mansion, it doesn't even affect the median? Why is that, Rachel? It totally blows the mean right out of the water and just totally distorts the mean. But why doesn't it affect the median? I don't know.
Is an outlier number?
Good. Who said that?
Rachel. No,
Rachel,
quiet.
your
Wyatt.
That's a good answer, Wyatt. Outliers can really screw up the mean. Now, an outlier is a piece of data that's so far out there, that's why we call it an outlier. It's so far out there, it's all by itself. All right? That's an outlier. Kind of like an example, when I met Harold Hamm, very nice gentleman. In fact, he donated about $1.2 million to Northwestern Oklahoma State University Enid campus. And he's the one that actually bought our bronze statue right out here of the horse and rider for Enid, Oklahoma, the Enid campus. And at the presentation, now keep in mind he's worth at least $8 billion, and that was back when he gave the presentation. I think Continental Resources stock has gone up quite a bit since then, so he's probably worth 10 or 12 billion by now, right? But anyway, so as he was, he's really a nice gentleman, very generous, and his whole family was sitting there, and he said, it's nice to be here with my family as they watch me give away their inheritance. Now, $1 million, oh, this is a good percent problem, a little retrieval here. Pretend that Harold Hamm's, you might have to write this down. I think I'm going to have to write this down. $10 billion, so write $10 billion down. That's a lot of zeros, isn't it? I think that's million, billion, all right. So then he gives away $1 million. So 1 million. So what percent is 1 million out of 10 billion? I'll give you a little chance to work on that. It's a pretty low percent. What percent boy, that is a low percentage, isn't it? So that's why we were all laughing, because we all knew that when he gives away $1 million out of his 10 billion, that's just an absolute joke, isn't it? All right. It's a tough one. It's a tough one. I'll give you a hint on how to do it in case you have no idea. He gives away $1 million. He has a net worth of $10 billion. So that's what we need to do right in here. We need to do this math problem. And then convert that into a percent. All right. Does anybody have an answer? Go for it. Be gutsy. Be brave. .01% is absolutely right. Now let me show it, at least that's what I got. We could both be wrong on that, John T, but at least we'll be wrong together, right? Okay.
Yes, sir.
So here's how I did it. I put the million over 10 billion, and then I just started dividing numerator and denominator by 10, meaning I can, it's scary, but I can use that, the C word, cancel. I'm dividing numerator and denominator by 10, so I get 1 over 10,000. So this is the same thing as 1 over 10,000. Now 1 over 100 would be 1%. 1 over 1,000 would be 0.1%. 1 over 10,000 would be 0.01%. That's it. So Harold Hamm gave away 0.01% of his net worth. Okay? So we won't go there, but some of you, if you're a normal college student, your net worth is probably not even 10 grand. I'm just remembering back as a college student, my net worth was, even in my senior year of college when I had my 66 Volkswagen that was worth $1,000. Okay? See, this is fun, analogy-wise. When I was a senior in college, my net worth was about $1,000. That's all I had was my VW Bug, just about. If I gave away $1, that was actually 0.1% of my net worth. And so it was, if I gave away 10 cents, this is just what blows your mind, at least blows my mind. If I gave away 10 cents when I was a senior in college, that would be the same percentage of my net worth as Harold Hamm giving away $1 million. Now, does that blow your mind, Rachel? It does mine.
Yes, it does.
So when I was a senior in college, if I gave away 10 cents, that would be the equivalent percentage-wise of Harold Hamm giving away $1 million. Okay? That affected our net worth the same percentage. Well, anyway. So let's see, I have about 8 minutes left. This is awesome. Now, this is related to big concept number 4. What we're talking about right here, I have it listed as big concept number 4. I'll list it as number 3 today. Big concept number 3 today is the concept of the bell-shaped curve. Not the gel-shaped curve, the bell-shaped. And in parentheses, I'm going to put in outliers. Okay? See, certain things, net worth is one of them. They don't follow the nice bell-shaped curve. I mean, you know, you got your net worth, something like that. Oh, that should be a nice bell-shaped curve. Well, no, because you got Harold Hamm so far out here to the right with his $10 billion of net worth, I can't even get it on the graph, can I? It's an outlier that's so far out there because, oh, let's pretend that the average net worth in Enid, oh, let's even say it's $100,000. Okay? Let's say the average net worth in Enid is $100,000. And so if we go one standard deviation up, we'll talk more about this on Friday, one standard deviation down, that captures about 68% of the population in Enid, 34% on each side. And so if we went one standard deviation up in Enid, let's just, I'm going to make the numbers really simple. Let's say it's 200,000 here, and let's say, no, that wouldn't be right because otherwise we'd not have zero. Sorry. I got to make up better numbers. This is 150,000 here, and so over here, this would be 50,000 would be over here. In other words, if I said 68% of the people in Enid have a net worth between 50,000 and 150,000. Just pretend that that's true. I don't know if that's true or not. Probably not, but it's it's close. It's reasonable. All right. So if I said every inch on my graph is 50,000. every inch on my graph is 50,000. Every inch on my graph is 50,000. So in other words, to go from here to 1,000,000, I'd have to go 9 inches, right? Because that's 900,000, so I'd have to go 9 inches. So to get my graph, I'd have to go 9 inches to the right, 9 inches to the right to hit 1,000,000. That would be for 1,000,000. Okay? I'd have to go 9 inches to the right for 1,000,000. Now just think about this. You got 9 inches for 1,000,000. Start thinking about this now. 9 inches for 1,000,000. I would have to go to hit a 10,000,000. I'd have to go 90 inches. Okay, we're talking about ratios now. Here, oh, that's last chapter. 9 inches is going to represent 1,000,000. Okay, so 90 inches would represent 10,000,000. Okay, 900 inches would represent 100,000,000. 9,000 inches would represent 1,000,000,000, and 90,000 inches, I'm trying to get you to feel the power of the outlier. I would have to go 90,000 inches to the right of the mean. This is mean, by the way, now. We're talking mean, not median. I'd have to go 90,000 inches to the right. This is not even fair because I am having a blast. Let's see how many inches are in a mile, just for the fun of it, okay? It's 5,280 feet in a mile. Times that by 12. And now times that. Oh, so there's 62,000 inches in a mile. Do you get the picture here? For me to put Harold Hamm on the graph, that is not Harold Hamm, because Harold Hamm on the graph has to go 1.5 miles to the right. Wow! Now do you catch the concept of the outlier? The outlier, Harold Hamm, is not out there just even 3 feet. Harold Hamm, if this represents net worth, Harold Hamm is out there 1.5 miles. So actually, net worth does not have a nice bell-shaped curve to it, because we assign probabilities on each standard deviation as we go out. We say, well, there's about a 34% chance that you're going to have, 150, and then there's less of a chance, less of a chance, less of a chance, less of a chance. According to probability, Harold Hamm shouldn't even exist. This is why you have to be able to identify data as, is it bell-shaped curve? We affectionately call that Gaussian. We name it after a guy named Carl Gauss, who is a tremendous mathematician. Or is it Mandelbrodian, which means it doesn't fit the bell-shaped curve, means there's outliers. You don't have to know how to spell these. But the thing of it is, it doesn't fit the bell-shaped curve. The outliers totally mess things up. Now, height, that fits a nice bell-shaped curve. I'll go over this a little bit more on Friday because we're out of time right now. But height fits the nice bell-shaped curve. Weight fits the bell-shaped curve. See, here, just quickly, because I'll wind this up and then let you go. The reason height fits the bell-shaped curve, what's the tallest person on the planet, Jonte? Tallest person on the planet.
7'6".
Yeah, 7'6", even if you said 8'3", even if you said 9'1". See, there is no person out there that's 23,000 miles tall, right? See, so height fits the bell-shaped curve. Weight fits the bell-shaped curve. What's the heaviest person on the planet? Robert.
2,000 pounds.
Maybe 2,000. That'd be a good question. I don't know. You can put that for extra credit. Maybe it's only 1,200. I don't know, But 2,000, yeah. But for sure, there's no person on the planet that weighs 40,000 tons. See why it's not? It is still bell-shaped curve. But net worth is not bell-shaped curve. Because Harold Hamm, he's 1.5 miles from the mean. I'll let you go. We'll talk more about this on Friday. Good job today.